Hey everyone, welcome back. This is lesson 4-5, matrix inverses and solving systems. The objectives for today, you're going to be able to determine whether a matrix has an inverse, and you're also going to be able to solve systems of equations using inverse matrices. Your vocabulary for today is going to be multiplicative inverse matrix, matrix equation, variable matrix, and constant matrix. A matrix can have an inverse only if it is a square matrix, like a 2 by 2 or a 2 by 3. But not all square matrices have inverses. If the product of the square matrix A and the square matrix A inverse is the identity matrix I, then A times A inverse is equal to A inverse times A, which is equal to I, the identity. And A inverse is the multiplicative inverse matrix of A, or just the inverse of A. So basically all that's saying is that if you had, say, just using numbers, not matrices, 5 over 1 times 1 over 5, that's the same as 1 over 5 times 5 over 1, and that's all equal to 1. So that is the multiplicative inverse matrix, if these were all matrices. Okay. So remember, the matrix identity has ones on the main diagonal and zeros everywhere else. So you're going to have ones on the main diagonal, zeros everywhere else, and that's going to be what your matrix identity looks like. And if it were an matrix identity of a 2 by 2, it'd be ones on the main diagonal and zeros everywhere else. All right, let's try an example now. It says determine whether two matrices are inverses. So this is actually a problem that I'm going to let you use your calculator on. And so in order to determine whether the two given matrices are inverses, we're going to multiply, just like if they had been regular numbers. If it had been 5, and I wanted to know if the number 1 over 5 was the inverse of 5, I could just multiply those together, and I would get 5 over 5 equals 1, my identity. So by multiplying my inverses, if I get 1, I know that 1 over 5 was actually the inverse. And that's pretty obvious to see because we know it's just the reciprocal. However, when we have a large matrix and we're trying to find if another matrix is the inverse, we have to multiply it out together to see if we get that identity inverse again. All right, so let's try this. We're going to get the calculator out and give it a try. So let's go. Okay, sorry, I had to get through all of that to get us back into our mode here. I'm back on now, so let's go. Let's take a look at our calculator and see if we can do these problems. So I'm going to go ahead. When you get your computer on, you want to go to Edit and then Enter. And I've already put these in for us, but you can see 1, 5, 4, and 8 are right in the order. 1, 5, 4, and 8. It's a 2 by 2. I'm going to go and let's look at our next one. Let's edit. Look at B, and it says negative 0.667, which is the same as a negative 2/3. I just put it in 5. You just have to put in 5 divided by 12, enter, and that's going to give you what the actual decimal is, 0.41667. Okay, so now that we have our matrices entered incorrectly, we're going to go second and quit, and I'm going to clear this. And so let's take a look and see. We want to go back to our matrix 1, enter that, and we're going to click times, and then we're going to go to matrix, and let's go to B, enter that. So if these two, when you multiply them together, if we get the identity matrix, we know that it's an identity, or that these are inverse. And sure enough, 1, 1, that gives us the ones in the diagonal, zeros out here. So that tells us that these are inverse of each other, because when they multiply together, you get the identity matrix. Okay, so here we go. And the product is the identity matrix, so the matrices are inverses. All right, let's try another one. I'm going to pull our calculator back up again. This time we're going to look at, let's just check our math here. We're going to go to Edit, come down to C, which is where I put these. So 101, 101. 110, 110, and 011. If you don't know how to enter all of these, you may need to go back and refresh your memory a bit. Again, I'm going to edit. I'm going to edit D this time. And notice I have 1/2 here, but 0.5 here, and that's the same. Just have a negative there, a negative up here, and a couple of negatives on the bottom row. So it looks like our matrices are both correct. So let's say second quit, clear that out. We're going to go second, and we're going to go to the C matrix, is where our first one was, and we're going to multiply it times our D matrix times D, and that's enter, and then we're going to enter it. And notice that I have 1, 1, but I don't have a 1 on my final diagonal here. And I don't have all zeros everywhere else. I have a -1 up here. And so far we can say this is not an identity. Let's just check the other way around. Let's go second D first. Okay, so let's go down to D, enter, and then times second C, enter that, and our new matrix, nope, it's not the identity either. I've got 1, 1 on our main diagonal, but I have a 0 on the last one. So I don't have all 1s on the main diagonal, and I don't have all zeros. So that is not an identity. Okay, neither product is the identity matrix, so the matrices are not inverses. All right, and one more for you to try on your own. Go ahead and give this one a try, and then put your video on pause, and then come back and give it a check. Okay, so one more time, let's just check and make sure. I'm going to have our first matrix is in E, and actually I need to edit that first, so let's go to edit. Edit, and I want to go to E. I have -1, 0, 2, 4, 1, -1, and 2, 0, 1. All right, so we know we've got that one right. And now let's go to our F. I'm going to go to edit first, down to F, enter, and -0.2, 0.4, 1.2, 1, -1.4, 0.40, and 0.2. So I have all of my entries incorrectly. I'm going to go ahead and quit, clear this. I'm going to say I want matrix E times matrix F. When I multiply them together, I do get the identity. The ones are all in diagonals and the zeros are everywhere else. We could just multiply it the other way around too. Matrix F times matrix E and once again I get the identity matrix. So I know that E and F are the inverse of each other because when they multiply together they give us the identity matrix. Okay, so now we're going to keep on moving. I'm going to, it's going to take just a second for me to get us moved back in, and Let's see if I can get you back online here. Okay, so now that you've been able to take two matrices and multiply them together, and if the resulting matrix is the identity matrix, which means it has the ones along the main diagonal and zeros everywhere else, you know that you are multiplying a matrix by its inverse. Well, now we want to find out, what if we're given a matrix and we want to find out what its inverse is? All right, so we have a formula that we're going to follow. And the formula for an inverse of a matrix is going to be this. We're going to take a matrix, let's just call it A, and it has the points A, B, C, and D in it. Okay, so this A to the -1 tells us that we're looking for the inverse. And the formula to find the inverse of A is we're going to take 1 divided by the determinant of A, and then we're going to multiply it by this new matrix, which is kind of similar to our A, B, C, D, but notice that we take our A and D and we flip them. Okay, up here I have A up here, and now I have it down. My D was down here, and now I have it up. Okay, so we're going to flip those, and all we're going to do to the C and the B is just take the opposites of them. So we're going to take the opposites of those. So that is the formula for finding the inverse. Well, what happens if the determinant is 0? Well, if the determinant is 0, then 1 over 0 is undefined, so you can't really multiply or anything by an undefined fraction. So a matrix with the determinant of 0 is said to have no inverse. It is called a singular matrix. Let's try an example. It says find the inverse of the matrix if it is defined. First of all, we need to find out if it is defined, and so to do that, we're going to find the determinant. So remember, in order to find the determinant, we have to take the diagonals, 4 times 1, and subtract it, minus 2 times 3, and so 4 minus 6 is -2. So our determinant is -2. That tells us that this matrix does have an inverse. So now let's use our inverse rule to find it. So here's our inverse. So we're going to take our original matrix, which is given up here, 4, 3, 2, 1. And in order to find the inverse of it, we're going to take our 1 over. See, it says 1 over the determinant. And our determinant was -2, so it's 1 over -2. This is a scalar. We're just going to have to multiply each one of these. -1/2 times 1 is -1/2. -1/2 times -3, that's a positive 3 over 2. -1/2 times -2 is actually a positive 1. And -1/2 times 4 is a -2. So now we have our inverse matrix. And if you wanted to take your calculator and type in your matrix 1 as 4, 3, 2, 1, and multiply it by this matrix, you would end up with the identity matrix is 1, 1, and zeros on the other side. So that's what it should look like. All right, let's try and find the inverse of this one if it's defined. So again, the very first thing we have to do is find the determinant to see if it's even defined. So when we multiply our diagonals together and then subtract the other diagonals, we actually end up with 0. So in this case, our determinant is not defined, so the matrix does not have an inverse. Okay, try this one. You can try this one on your own. Turn off the video for just a minute and then come back and let's do it together. Okay, so the first one says to find the inverse if it is defined. So the first thing we have to do is to find out if it's defined. So the first thing we're going to do is search for the determinant. Okay, so remember, in order to find our determinant, we're going to take our diagonals, multiply them together, and then find the difference between the two. So first check, and when we do it, we find out 3 times -2 minus 3 times -2 is -6 minus -6, so we have a determinant of -12. All right, so now that we have that, the determinant is -12, so we know that the matrix does have an inverse. All right, so how are we going to find the inverse? Well, we need to follow our formula again. And so the first thing we're going to do is say negative 12. So it says take 1 over our determinant. So here it is, 1 over negative 12, or negative 1/12 now. All right, and we're going to multiply it by, we've got to change up our matrix just a little bit. Our original matrix was 3, 2, 3, 2, 3, negative 2. So what we have to do is switch our negative 2 and our 3. So here the negative 2 is now in this spot and the 3 is this spot. And we have to change both of our C and the B and C to the opposites. And so now we have our new matrix. We can multiply by 1 over the determinant. And again, since this is just scalar, we can just multiply right back through. So negative 2 times negative 1/2 is a positive 1 over 6. We multiply this together, we get positive 1/6 again. Multiply this times our negative 3, and we get 1/4. And multiply this by our 3, and we get negative 1/4. So yes, this matrix does have an inverse, and this is the matrix. And again, you could put these numbers in your calculator and multiply it by your original matrix. And you would get your new identity matrix, which would just be 1s in the diagonals and 0s in the other place. Okay. All right, you can use the inverse of a matrix to solve a system of equations. This process is similar to solving an equation such as 5x equals 20. What you would do if you wanted to solve that, you would multiply each side by 1/5, which is the multiplicative inverse of 5. So you would say 5x equals 20, multiply both sides by 1 over 5. 1 over 5 times 5 over 1 is 5 over 5, which equals 1. And 20 times 1 is 20 over 5 equals 4. So we would be able to say x equals 4. Okay, so as long as you understand that concept, I'm going to erase all this and we're going to keep moving on. All right, so we're going to do that. Keep that in mind, that process that we're doing. And let's keep moving. Okay, so to solve systems of equations with the inverse, you write the matrix equation. So here is a vocabulary word for you, the matrix equation. And this is the matrix equation, AX equals B. Okay, so what is A, what is X, and what is B? Well, A is the coefficient matrix. All right. X is going to be our variable matrix, and B is going to be our constant matrix. Okay, so we're going to have a coefficient matrix, a variable matrix, and a constant matrix. All right, and our matrix equation is right here. It's going to look like AX equals B. And notice it's kind of this similar right here to 5x equals 20. So you can kind of guess what we're going to be doing. All right, here's a picture of what it's going to look like. We're going to be given a system. And remember, a coefficient, if there's nothing there, is an understood 1. All right, so the coefficients of this matrix are 1, 1, 2, and 1. All right, so there's our coefficient matrix. Now we have our variable matrix. We haven't written it like this before, but we can write a matrix that says x over y. This is our coefficient matrix because we have x's and y's, and we write it like this, x, y. And then we have a matrix with our constant, which is our answers. In this case, it's the constants, 8 and 1. So this is how we're setting up our matrix expression, and it's in the form A times X equals B. Okay, so think back to your algebra. If we have AX equals B, we would normally multiply both sides by A, which is the inverse of A, multiplicative inverse. And then the A's cross out, leaving us with the X, and that leaves us with B times 1 over A, the inverse, all right? So we're going to do the exact same thing, but this time we have to do it with matrices instead of just X's. All right, one word of caution before we move on. Matrix multiplication is not commutative. I've said this before, but I want to reinstate it again. So it is important to multiply by the inverse in the same order on both sides of the equation. So A inverse is going to come first on each side, all right? So let's just not forget that. A inverse is going to come first. So don't forget, multiplication, we know that 2 times 3 is the same as 3 times 2, right? That means it's commutative. But matrix multiplication is not like that. It's more like subtraction. We know that 2 minus 3 is not the same as 3 minus 2. So you have to keep the order the same on both sides of the equation, and the inverse is going to come first on both sides. Okay, so that's a word of caution for you. Let's try an example here. It says, write the matrix equation for the system and solve. So the very first thing we want to do is figure out what the determinant is, and if it is, even has an inverse. So we're going to set up our matrix equation, and so let's take a look at it. We're going to write the coefficient matrix, the variable matrix, and the constant matrix. All right, the coefficient matrix is going to be 2, 5, 5, and negative 3. Our variable matrix, we have x and y. It's going to be x over y. And then here's our constants, 0, 31. So let's take a look at that. 2, 5, 5, negative 3. That's these numbers in here. Our x and y, and then our constants, 0 over 31. 0, 31. So now we have set up our matrix equation. And just like in algebra, if we had 5x equals 20, again, I just want to keep saying, we're going to multiply by our inverse. All right, well, we have to find the inverse first. So we're going to have to find the inverse of this matrix right here so that we can multiply it to the other side. So let's go ahead and find the inverse. The first step to finding the inverse, we need to find the determinant. Okay, so let's remember, how do you find the determinant? You multiply your diagonals. 2 times 3 is 6, minus 5 times 5 is 25. So 6 plus a negative 25, and actually 2 times negative 3. So negative 6 plus negative 25 equals negative 31. So we do have a determinant, and it is negative 31. So let's keep that in mind. Okay, so here we have our equation again. Let's go ahead and write out our matrix equation one more time. Remember, the matrix equation to solve for our x and y is going to be our coefficient equation times our variable equation. It's going to be our x and y. Is going to equal our constant equation. All right. And we found out that our determinant equals negative 31. All right, so the first thing, let's kind of look at this equation right here and kind of think of it in our algebra terms. This would look like 5 times x equals 20. And if I wanted to solve for my x, I would multiply by the multiplicative inverse on both sides. So here we are. We need to multiply our matrix here by the multiplicative inverse. And our matrix then is we have to find the inverse. So we have to follow our formula to find our inverse. So the formula to find our inverse says to take 1 over the derivative. So that's going to, I'm just going to go ahead and print it all out here for you so you can see it. So here's our original matrix. And we're going to take 1 over the derivative. Okay, that's what it says. Take 1 over the derivative and multiply it by this new matrix. Now, how do we get the new matrix? We take these two and switch them, okay? The two diagonals, in the two numbers in our first diagonal, and we switch them. So the 2 and the 3 get switched. The 3 is now on top, the 2 is now on the bottom. All right, and our 5s, we're positive over here. We just take the opposite of those. All right, so this is just multiplying a scalar by a matrix, and so we just multiply each one. 0 times negative, over negative 31 times negative 3. Is there. This one becomes there. 1 over negative 31 times negative 5 comes to here, and the 2 comes here. So now we can see in blue, this is our new inverse. Okay, so now what we're going to do, if we multiply our inverse by our original matrix up here, we're going to get 1, so that'll go away. All right, and now we have to multiply it by our solution set. Okay, so we're going to take the inverse and multiply it by our solution, or our constant matrix. Okay, so now we are going to multiply. So here's our inverse, and here's our constant. So now, again, we just have to multiply. And so we're going to do this time we have to check and see if we can multiply. This is a 2 by 2, and this is 2 rows by 1 column. So our new matrices is going to be a 2 by 1. Okay, so let's just start multiplying. Remember, you multiply the first row times the first, in this one, it's going to be, there's just 1 column here. And we just start multiplying through. And so this would be 3 over 31 times 0 is going to be 0 plus 5 over 31 times 31. So 5 over 31 times 31. The 31's cross out. So our first place is going to be 0 plus 5 is 5. Okay? And then our second one, and the second column is going to be 5 times 0 over 31. That's going to be 0. And then 2 over negative 31 times this, I know that's getting kind of sloppy, is going to be 2 over negative 2 over 31 times 31. And the numbers cross out, so our other point is a negative 2. And so we can see that our solution is going to be, x is going to be 5, and y is going to be negative 2. All right? So here's our solution. The solution is 5, negative 2. All right. Not too. Okay, here's one for you to try on your own. Why don't you turn the video off for just a minute and give it a try, see how you do, and then turn it back on and let's go from there. Okay, so the first thing you should do is write your matrix equation and then solve. So here's our matrix equation. It's the coefficient equation times the variable equation times equals the constant. Okay, so remember that's like AX equals B. And in order to solve for that, we would multiply by the inverse of A, and that way we could solve for B. Solve for X. So, how do we find the inverse of A? Well, first of all, we have to find the determinant and see if there even is a inverse. So, set up your matrix equation, and then the next thing we want to do is find the determinant. Remember, to find the determinant, we take the diagonals, multiply them together, 3 minus 2, all right, and we end up with 1. So our determinant is 1, so keep that in mind. Okay, so now that we have found our determinant, we can go ahead and find the inverse of A. So we start out with our coefficient matrix, 1, 1, 2, 3, and we want to find our inverse of that. So remember, we take 1 over the determinant. We decided what our determinant was, and we have to multiply it by a new matrix. And this new matrix is going to take our old one, which was 1 and 3, and flip these two numbers. So now we have a 3 and a 1 here. And then we just have to put the opposites of the other diagonal. All right, so when we multiply all of this by, which is actually 1 in this case, we're going to have the same numbers. 1 times 3 is 3. 1 times negative 1, negative 1. 1 times negative 2, negative 2. And 1 times 1 is 1. So now we have our inverse matrix. So remember, in a regular math problem, if we have 5x equals 20, we're going to multiply both sides by the inverse. Well, we have our inverse now, so we're going to multiply. Now, I want you to be careful, because notice how I always write my inverse on the outside here, but you can't do this. If I have the inverse on this side, on this multiplication problem, I also have to keep it on the same side. So I'd have to have it over here. So we have to be really careful about where we put that inverse. Okay, so in order to multiply, notice they put the inverse on the inside here. Okay, so we're going to keep it in the same place as where I did before. So now we're going to just multiply through here. 4 times 3, we have to, before we can multiply, let's go ahead and make sure that we can multiply. This is a 2 by 2, and this is a 2 by 1, and our columns and rows do equal. So our new matrix is going to be 2 rows by 1 column. All right, so now let's do it. We have a 3 times 4 is 12 plus negative 1 times 9 plus a negative 9. 12 plus a negative 9 is 3. All right, and let's do the other one. Negative 2 times 4 is negative 8 plus 1 times 9 is 9. Negative 8 plus 9 is a positive 1. So we can see that our XY matrix, so we have XY matrix is equal to 3 over 1 matrix. So that tells us that our X equals 3, our Y equals 1, so our solution is going to be 3, 1. All right, and I hope that you were able to find that. All right, so that's the end of our lesson today. Don't forget the little message that I gave you in the middle of our lesson. It will help you a lot on your test. So hope you have a great day, and I'll see you in class. Bye now.